Next example on Simpson's rule. That the example is find the value of integration 3 to 7 x square log x dx by Simpson's rule with 4 strips or 4 sub-intervals. That is, we have to divide this interval 3 to 7 into 4 subparts, 4 sub-intervals, and each of length is what? Then h is what? B minus a by n. That is, b is what? 7. That is upper limit, and lower limit is a 3, and divided by n, number of sub-intervals are 4, because here given in an example that use Simpson's rule with 4 strips. And so, and the given function is what? X square log x. So here is log x, means log x with base e. Base is not mentioned, then the base is e. So this is log x with base e, and this is the function fx, x square into log x, and a is 3, b is 7, that is lower limit, upper limit, and number of sub intervals are 4, and therefore h, that is the length of each interval, is what? B minus a by n, the formula, and that is 1. B is 7 minus 3 and divided by 4 is 1, and therefore prepare the table that the first row is the values of x and the second the values of y or fx. And what are the values of x? Starting from 3, because the lower limit is 3, and next value is what? By adding h in this value we get the next value, that is 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, 6 plus 1 7. So these are the end points of the sub intervals. So number of sub intervals are 4, but the end points are 5 in number. 1 2 3 4 5 end points are 5 in number, and the corresponding values of the y or the function fx are what? That is, substitute 3 in fx as x is equal to 3. What do we have? 3 square 9 into log 3. So how we can calculate this log 3 by using calculator? Use the knob ln, because the base is e. So log 3 by using calculator, use knob ln, because there are two knobs on the calculator, log log and ln log. So the ln means the base e, and log means base 10 while using the your calculator. But if you read the books of mathematics, then log log x means the base is e, because the base is not mentioned. So log log x means the base is e, but while using your calculator, if ln is the notation, then it means that the base is e, and log means the base is 10. But here log x in mathematics, log x means log x with base e. So use the knob ln while calculating while calculating log 3. So find ln 3, that is and into x square, that is 9, and the answer is 4.2941. And similarly find the value of fx or y at 4, that is substitute x is equal to 4, then x is equal to 5 and 6 and 7, and these are the values. And these values are what? The values of y, starting from y0, y1, y2, y3, y4. Don't start from y1 notation, y1. This is from y0, and then the Simpson's 1/3 rule. Here is the instruction, use Simpson's rule, but here is no here is the number of strips are, or number of subintervals are 4, means even in number, and that's why the Simpson's 1/3 rule is applicable for this example. Simpson's 3/8 rule with 4 strips is not possible, because when Simpson's 3/8 rule is applicable, if the number of sub intervals are multiples of 3. So there is question in the exercise on this knowledge. What is the question? Observe this question. Question in the exercise. So the question on this is what? Is it possible to apply Simpson's 3/8 rule if the number of subintervals are 10, for example 10? So the answer of the question is the Simpson's 3/8 rule is not applicable if the number of intervals are 10. because the Simpson's 3/8 rule is applicable only if the number of subintervals are multiple of 3. Like that, another question is what? Is it possible to apply Simpson's 1/3 rule if the number of intervals are 5? So again, the answer of the question is what? The Simpson's 1/3 rule is not applicable if the number of subintervals are 5, because the Simpson's 1/3 rule is applicable only if the number of subintervals are even in number. So in the next lecture, we will see such examples. Then answer of this problem. What is the Simpson's 1/3 rule? Integration 1 to 3 1 by 1 plus x dx. That is the given integration. Here is not a 1 by 1 plus x. The integration is what? This is another problem. So right here, instead of this, write 3 to 7 x square log x dx. Here write 3 to 7 x square log x dx. So here is printing mistake. Here write left side as 3 to 7 x square log x dx is equal to h by 3 RHS y0 plus y4. First point plus last point. First point plus last point. First value of y plus last value of y plus 2 times even suffix. So even suffix are what? Y2 is only even suffix value of y. Y4 is there with even suffix, but y4 is present in the first bracket. So except 2 times in bracket is what? The even suffix values of y, but there is only one values of y whose suffix is even. This is the y4 is the value of y with suffix even, but it is the last value. So except first and last. So again here 4 in bracket, addition of the values of y whose suffixes are odd, but except first and last. So what are that? Y1 and y3. These are the values of y with odd suffixes 4 times. So this is the Simpson's 1/3 rule, that addition of first and last plus 2 times even suffix plus 4 times odd suffix values of y. And then 1 by 3, the value of h is 1. So 1 by 3 and substitute y0. Y0 is 4.2941 plus y4 is this value plus 2 times y2. Y2 is this, and 4 times y1 plus y3. Substitute all the values and find the answer by using calculator, and the answer is 77.0794. This is the integration 3 to 7 x square log x dx. So right here x square log x dx. Then next problem, evaluate integration 1 to 5 x by 1 plus x dx by trapezoidal rule and by Simpson's rule. That is either Simpson's 1/3 rule or Simpson's 3/8 rule. So we divide first this interval. This is fx, x by 1 plus x is fx, a is 1, b is 5, and then we have to decide that how many subintervals of this 1 to 5 under trapezoidal rule and Simpson's 1/3 rule. So here n is 4, that is we are going to divide this interval 1 to 5 in 4 subintervals. This is depend on you, that how many subintervals are obtained of this interval 1 to 5. So here n is 4, that is n is 4 is convenient to us because what is the h? 5 minus 1, that is 4 by 4 is 1. So we divide this interval, number of intervals, subintervals. Also we can divide this number of subintervals. N is equal to 6 or 7 or 8. But if we divide this n in odd number figure, that is if we divide this interval 1 to 5 in 7 parts, then trapezoidal rule is applicable. But Simpson's 1/3 or Simpson's 3/8 rule is not applicable. That's why we divide number of subintervals if for which the trapezoidal rule as well as Simpson's 1/3 rule is applicable. And these 4, the number of subintervals are even in number, means trapezoidal rule there is no condition, but under Simpson's rule there is condition that the number of subintervals must be even in number. And so take 4. Instead of this 4, we can also take 6 or 8. If you take n is equal to 8, then h is obviously 0.5, and we get 10 values of x and 10 values or 9 values of x and 9 values of y if we take n is equal to 8. So here we take n is equal to 4. Here is no instruction about number of sub intervals. In the previous problems, there is the instruction about sub intervals, that is 4 steps. So n is 4, but here is no instruction, and that's why we decide the number of sub intervals. This number n is equal to 4 or 5 or 6 or 7 or 2. So n is 4 because it is convenient to solve the example. N is 4. So h is what? B minus a by n. We can also divide this number of sub intervals, that we can also take n is equal to 6 or 8, and then h is what? B minus a by n, that is 5 minus 1 divided by that is 4 by 4, that is 1. And then prepare this table, the values of x, the values of y. So starting from 1, because lower limit is 1, and then adding h in each, we get these values of x, 2, 3, 4 and 5. So, and the corresponding values of fx is x by 1 plus x. So x, substitute x is equal to 1, then we get answer 1/2. Then substitute x is equal to 2, we get answer 2 by 3. Then substitute x is equal to 3, we get answer 3 by 4. In this way, corresponding value to 4 and 5, and naming these values of y or fx by y0, y1, y2, y3, y4. So, and write the trapezoidal rule for the integration 1 to 5 x by 1 plus x dx, that is a to b fx dx is what? H by 2. The trapezoidal rule is what? H by 2 in bracket first value plus last value. So what is the first value? Y0. Last value is y4 plus 2 times the remaining. What are the remaining? y1, y2, y3. So this is the trapezoidal rule. Substitute the values and find the answer. The answer is what? 2.8833. Then Simpson's 1/3 rule. The same integration 1 to 5 x by 1 plus x dx is h by 3, because the coefficient of this bracket is what? H by 3 in 1/3 rule. In the 3/8 rule, it is 3h by 8. So in the trapezoidal rule, it is h by 2. First value plus last value plus 2 times even suffix plus 4 times odd suffix, and then substitute the values and find the answer 2.9. This is 2.8, this is 2.9 by using Simpson's 1/3 rule. And the next problem is evaluate integration 0 to 1 by 1 plus x square dx by using trapezoidal rule, by using Simpson's rule or Simpson's 1/3 rule or 3/8 rule. We can apply either Simpson's 1/3 rule or 3/8 rule. Hence, find the approximate value of pi. So first we divide this. This is fx, that 1 by 1 plus x square is fx. A is 0, b is 1. Then take n is equal to, that is number of sub intervals. This is depend on you. The number of sub intervals are not given in the problem. So we take n is equal to 4 or 6 or 8, because we have to use the Simpson's 1/3 rule, and that's why the number of sub intervals must be even in number. So take n is equal to 4 or 6 or 8. What is convenient? The 4 is convenient, because if we take n is equal to 4, then h is 0.25. That is this interval 0 to 1 divided into 4 sub intervals, and each of length is what? 0.25. And then write the values of x starting from 0, because the lower limit is 0. So here is 0. Then add h, and next value are obtained, and the corresponding values of fx or y are what? Substitute x is equal to 0, x is equal to 0.25, x is equal to 0.5, 0.75 and 1, and we get the values of fx or y. And these values are what? y0, y1, this is y8, this is y3, this is y4. And then write the trapezoidal rule. So integration 0 to 1 by 1 plus x square dx, that is the given integration, is equal to h by 2 in bracket first value plus last value plus 2 times remaining, addition of remaining, and then substitute the values, we get the answer 0.7828. And then the same problem by using Simpson's 1/3 rule, and integration 0 to 1 by 1 plus x square dx is what? H by 3 y0 plus y4, that is first value plus last value plus 2 times even suffixes value of y plus 4 times odd suffixes of values of y, except here is except first and last, here is also except first and last, even but what, except first and last. So and substitute the values, we get this answer 0.7854. so this is the value of integration 0 to 1 by 1 plus x square dx by using Simpson's 1/3 rule, 0.7854, and this is the value by using trapezoidal rule. And if we find actual answer by direct method or method of rules of integration, then what is integration of 0 to 1 by 1 plus x square dx? So integration of 1 by 1 plus x square dx is what? Is tan inverse x. This is the, what is the derivative of tan inverse x? Is 1 by 1 plus x square, and therefore the integration of 1 by 1 plus x square is what? Tan inverse x, and limit are what? 0 to 1. Then find the value at the upper limit, that is tan inverse 1 minus tan inverse 0. The tan inverse 1 is what? Tan inverse 1 is pi by 4, and tan inverse 0 is 0, and therefore we have the answer pi by 4. Value at the upper limit means tan inverse 1 minus tan inverse 0. You write one more step, that is equal to, the next step is what? Tan inverse 1 minus tan inverse 0, and is equal to tan inverse 1 is pi by 4 minus tan inverse 0 is 0. So answer is pi by 4. This is the correct answer. So pi by, but what is the answer by using Simpson's rule or trapezoidal rule? We have the answer of this problem, integration 0 to 1 by 1 plus x square dx is what? 0.7828. So here is pi by 4 is 0.7828, and therefore pi is what? Shift this 4 to right side, and then we get the answer 3.13. But actually, what is the answer of pi? 3.14. So this is the, actually these are the approximate answers. All these answers are approximate answer. And if you find by using Simpson's 1/3 rule this answer, so pi by 4, this is the answer of correct answer of this problem by using direct method, and the approximate answer by using Simpson's 1/3 rule is 0.7854. And if you count pi by shifting this 4 to right side, then we have the answer 3.1416. So by using Simpson's rule, we have the more accurate answer of pi than the trapezoidal rule. That is, this answer by using Simpson's 1/3 rule is more correct than the answer by using trapezoidal rule. The next problem is find the values of integration 0 to 6 1 by root 1 plus root x plus 1 dx by using Simpson's 3/8 rule. So we have to divide this fx. Fx is this quantity 1 by root x plus 1, and the a is 0, b is 6, and we have to take this n, that is number of subintervals. But here the instruction is what? Use the Simpson's 3/8 rule, and that's why take n as a multiple of 3, because Simpson's 3/8 rule is applicable if the number of subintervals are multiples of 3. That is, take n is equal to 3 or 6 or 9. Don't take this n very small, or then don't take this n very large, because if you take n as suppose 9, or if you take 12 or 18, then number of subintervals increase, and this calculation the values of x are if you take n is equal to 18, then the values of x are 19 in numbers, and calculation may be complicated. So don't take this n very large or very small. Take n as a 6 if you have to apply Simpson's 3/8 rule, or take 9 instead of this n is equal to 6. We can also try with 9. That is, the number of subintervals are 6, and therefore h is equal to what? B minus a by n, that is 6 minus 0 by 6 is 1. So take this n is equal to such a number that's that h is what? Maybe h may be integer. If it is possible, take n in such a way that this h is integer, or the number in point but not in fractional number. So n h is what? B minus a by n, that is 1, and then take prepare the table, that is the values of x, the values of y or fx, values of x starting from 0, because lower limit is 0. By adding h, we get the next values. 1 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6. That is, we get the upper limit. And these values, if you count these values, these are in 7 in numbers, because the number of intervals are 6. And then these values of x are called ordinates. So we have the 7 ordinates. The number of intervals are 6, but the ordinates are 7. And the values of y are also 7 in numbers. And how we can find the fx or y? That is, substitute x is equal to 0 in this formula, we get the value of fx. Substitute x is equal to 1, we get the value of fx. In this way, we get the values of fx or y, and naming these all these values by y0, y1, y2, y3, y4, y5, y6, and then write the Simpson's three-earth rule. So what is the Simpson's three-earth rule? Integration a to b fx dx, that is integration 0 to 6 1 by root x plus 1 dx is equal to 3h by 8. This is the coefficient of this bracket in the Simpson's three-earth rule, 3h by 8. In bracket, first value plus last value, y0 plus y6 plus 3 times, in bracket write the values of y whose suffixes are not 3 or multiples of 3, whose suffixes are not 3 or multiples of 3, and except first and last. So what are the suffixes? What are the values of y whose suffixes are not 3 or 3 multiples of 3? That are y1, y2. This y3 is what? Its suffix is 3, so don't write here. Then y4, y5. The y6 is the last value, so it is in the first bracket. So we have these values in bracket plus 2 times the values of y whose suffixes are 3 or multiples of 3, and that is only one y3. y6 is there whose suffix is multiple of 3, but it is in the first bracket. So except here write the values of y whose suffixes are 3 or multiples of 3, but except first and last. So y6 is not including this bracket. So, and substitute all these values of y0 to y6 in this formula. What we have this answer 3.2961. So these are some exercise on these 3 formula, that trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. So these are the examples on the derivative. In the next lecture, we are going to take this differentiation or derivative part. So first solve the examples from this from 4, exercise 4, number 4, example number 4. Start from this. These examples are on derivative, numerical differentiation. So after completion of that lecture, solve these 3 problems. So start from number 4, that is calculate these integration by using Simpson's rules with 4 steps, 8 steps, determine the error, and all the answers are given below the problems. So find the answers of all these problems and communicate me all these answers of the problems, solutions of these problems through the WhatsApp group, or and these are the problems. Some problems are also on the same trapezoidal rule, Simpson's 1/3 rule. This problem is again on the differentiation. So after completion of that topic, solve these problems. Taking 10 subintervals, obtain the Simpson's rule obtained by Simpson's rule the value of this quantity. Again integration by 10 subintervals, 10 strips. And here is the table is given. So if the table is given, then no need to find what the n or fx. So directly write area bounded by the curve x-axis and the extreme ordinates is equal to integration 0 to 4 y dx. So direct what we have to find in this problem, we have to find the integration of y dx from 0 to 4, and naming these points as y0, this is y1, y2, y3, y4, y5, y6, y7, y8. So number of subintervals are what? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ordinates means number of subintervals are 8. And so we can apply the trapezoidal rule or Simpson's 1/3 rule. And that is, what is the question? Calculate the area bounded by. So write directly the required area is equal to integration 0 to 4 y dx is equal to, and write the Simpson's 1/3 rule or 3/8 rule and find the answer. So solve all these exercise, all the problems given in exercise. If we have any doubts or any problem in solving these examples, communicate me through WhatsApp group or by mobile.